Okay, so let's continue. If the camera cannot be set properly, it is to your advantage. Okay, if you understand what I'm saying. Now, last time we have learned what is meaning of drift. Okay, so now we will derive a relation of drift to velocity. We will find a formula for that. See, let's start here. Drift velocity. This is physics and chapter 3. Okay. So, first of all, we'll talk about what happens without electric field, right? So, let's say in absence of electric field, let I free electron, let I free electron, let's take the result, have a velocity vi vector at any time. So sometimes the ith electron, there are so many free electrons, correct? There could be so many free electrons, but let's say this is the ith electron. It has the velocity vi vector at any particular time. Then I can say that the average of velocity of all the free electrons in the metal or in the conductor is average of Vi, okay, is going to be sigma Vi vector upon n. See, this is not average velocity, please do not get confused. Average velocity nothing. This is the average of velocity of all the free electrons. See the difference. We are not even finding the average velocity of one electron. We are finding average of different electrons. He has 2 pens, you have 3, you have 4, you have 5, like that. Then we find average. That would be average of the pens that you all have. Clear or not?
Yes.
Did you understand? So this is the average of the velocity of free electrons. It's not the average velocity. So if we add all the velocities and then we divide by n, what is n? What's n? When n is the number of free electrons. Then, do you realize that this is going to be 0? Why? Because of the random motion. Due to random motion of the free electron. Did you understand that? Or not clear? What is the meaning of random motion? If one goes here, the other will go that way. Third will go the other way. Like that, if at any particular time some are going towards the right side, then exactly the same number are going towards the left side. So like that, when you take the average of all the velocities, that is, you add all the velocities, v1 vector, v2 vector, v3 vector, like that, they are all in different directions. So when we add all of that, the total will be 0. Is that clear? That is the random behavior actually, right? Nothing else. Okay, if this was not 0, suppose you say that this is towards the right side, that means overall the electrons are moving towards the right side. If you say this is towards the left side, then that means overall the electrons are moving towards the left side. But we have neither, right? Electrons overall, they are neither moving left nor right. It's like that. Okay, random motion cancels everything. So this is what we got. In what? In absence of
Electric field.
That's very good. Absolutely sure.
Yes.
Okay. I'm erasing everything on the board. Now we'll start writing about what happens in presence of it. Okay. So it's that now if an electric field E vector exists within the conductor, let velocity of I electron V vector. Okay, so we'll have, I'm writing capital V for velocity, but this is a separate case. So capital Vi vector will be equal to Vi vector plus the velocity that is acquired by drift. Okay, because of electric field. You understand what I'm saying? Or not clear? Yes or no? And repeat. It's that if without electric field everything was moving here and here and here and here. Okay. If without electric field everything was moving everywhere in different directions. Now in presence of electric field what happens is that every electron will get a drift. That is, its original velocity would have been in this direction, but because of the electric field, let's say it gets a force in that direction, so the velocity will change by some amount, and now the new velocity will be in this direction. Did you understand? Yes or no? Okay? Or not clear? No. This is just drift. Think of it. This is a crow. Okay, this crow wants to fly there, and in absence of wind, the crow will fly there. But if there is a strong wind, then if there is a strong wind in this direction, then you will get an additional velocity in that direction. So its total velocity will now be this plus this. That is zero. Did you understand? By triangle law of addition. So it adds something. It adds something. But what does it add? Right? What does it add? So that's what we are going to talk about. Did you understand? What does it add? Now, so right now there is nothing special to put over here. Okay, you can still write it. It's not like you can't write it. You would say acceleration due to electric field and then torque. Okay, wow, to be very clear. But I just say that we will reserve this step for later. Someday I would say intuitive. Why? Because if there is electric field, it will give acceleration. It will give acceleration. Then the velocity acquired due to acceleration is A into T. Think about that. Velocity acquired due to acceleration. If acceleration is A and it happens for a time T, then the velocity acquired is how much? A into T. Now it's very connected. So this part is due to electric. But let me write it properly with explanation. But we will not write this step over here. We will get to it stepwise. Okay, by writing sentences. So let's follow that. So first of all, we will write that due to electric field, the electron gets a force F is equal to F vector equal to minus E into E vector. Okay or not? Right? While moving from one ion to another ion between successive collisions. Did you understand this sentence? What am I saying? That if suppose there is one ion and there is another ion and this electron is going from this ion to that ion. So while it will move from one to the other, at that time what will happen? It will get a force. Force from where? Force due to electric. Now why will it get force only while it is trying to move? You will remember last time the analogy that if there is a bird is sitting on a tree, now it wants to fly to the other tree. So while it flies, the wind will apply force on it and the bird will drift. But if the bird is sitting on the tree, the bird will not drift. Did you understand? If the bird is sitting on the tree, the bird will not drift. Okay? Okay or not okay? Sure. So we are saying that the electron gets that force only while it's going from one to the other, not continuously. See, that's the difference. एक बार bird tree पर बैसे जैसे, then the force will not act. Is that okay? And not only that, the moment it interacts with this ion, all the velocity whatever might have been given to this electron during the drift from here to there will be lost, because what happens is that typically when the electron collides with the ion, it will rebound in a random manner. It will rebound in a random manner. That is, એવું ન હોય કે આમ આવે તો એ આમ જ જશે. You understand what I'm saying? Right? Electron, basically what is really going on is that electron is captured by the atom for a short time. Note what is it? Electron is captured by the atom for a short time, and then it will release it again. I think we had this discussion last time as well. The question, why doesn't the electron get attracted to positive and it is captured? Yes, it is captured, but then it will be released back soon. So what is really going on is not just a collision, basically. It's much more than that. It's that electron is captured and then thrown out again. Did you understand? So it's that when it hits here, or when it goes over there and then comes out, its velocity would have changed completely. Its velocity would have changed completely. समझ पड़े છે? There will be random character. એવું નથી કે okay, it will go with 100 meters per second, it will hit here and bounce off like this with 100 meters per second. No, that is not happening here. સમજાણું? It is not like this. હવે પડી કે ન ખબર પડી? The velocity will become randomly changed. એને તો random behavior કહેવાય. નહીં તો એક ઇલેક્ટ્રોનની velocity constant જ રહે દરરોજ. Because all collisions at the microscopic level are elastic. સમજ પડે કે નહીં? If a proton interacts with a proton, the collision is always elastic. When electron interacts with electron, collision is always elastic. કેમ? એમાં થોડું friction હોય. ન જ હોય ને? Electron વચ્ચે friction થાય? Of course not. So, it's just that the moment it reaches there, everything, all the previous information, that becomes completely useless. Then it will start again. એટલે દર વખતે reset થાય. Every time the crow sits on the tree, the next portion is new for it. So what is happening is that we can say that force is only acting for a time between the collision. So I can say that if average relaxation time is tau. याद છે શું હોય relaxation time? Who remembers what is relaxation time? Okay, yes, Raj, what is it?
A successive collision વચ્ચેનો જે time
The time interval between two successive collisions. Is that okay or not okay? Time interval between two successive collisions. આ કેમ આવતું હતું? Antic theory of gases માં આવતું હતું ને? Do you remember?
Yes.
Okay. Right. Clear? So it goes from here to there, and meanwhile, how much time does it take to go from one to the other? That is called relaxation time. It is not fixed everywhere, remember, because everything is random. કોક વાર time વધારે લાગશે, કોક વાર ઓછો લાગશે. Okay, so that's why average. So if average relaxation time is tau, you can say that an electron will get acceleration. How much? A is equal to F by m E. M is with it? Mass of electron. Okay, that would be equal to E into E upon me in magnitude. Vector form માં લખો તો આમ. Is that clear? The electron will get an acceleration A vector equal to minus E vector upon m. For time tau. Why so? Because to go from one to the other ion, it takes a time tau. And that's why it will get acceleration only for that time. The moment it reaches the other one, everything is lost. And now once again the electron will start with a completely different velocity, different speed in different direction. Okay. So we can say, now we can come to this point. We can say thus Vi vector is equal to small vi vector plus minus EE vector upon ME into tau. Why is this so? Think of it. Without electric field, this would be the velocity of Vi. What is Vi? Velocity of the ith electron. Then we can say that without electric field, this is Vi. Small vi, capital Vi, say. But what is the contribution due to electric field? It's that when the electron will try to move, what will happen? It will get an acceleration. This acceleration is due to electric field. So that much will be added to its velocity. I hope that is clear. Because you can think of it like this, that when electron tries to move or starts to move from here, let's say with velocity Vi vector, then while it is going, it will get acceleration. Yes or no? How much acceleration? This acceleration. And then how much time will it take to reach the other one? On an average, it takes a time tau. So it will get, on an average, it will get a time tau to get accelerated. Another analogy to get it better. Think of a scooter. Scooter is specially designed. Okay, you run the scooter, accelerate it, it will get some acceleration for 10 seconds. Okay, then automatically brakes are applied and it will stop. The moment it stops, once again the scooter will accelerate for 10 seconds and then once again brakes are applied like that. So is there acceleration multiple times? Yes. Accelerates, decelerates, accelerates, decelerates, accelerates, decelerates. But will velocity continuously increase? No, increase. So after a particular time, everything gets reset. એવું થયું ને અહીંયાથી accelerate થવાનું છે, okay, more speed, stop. Then it will try to go the other way, again more speed, stop. So do you realize what is happening is, even though the electrons are in electric field and they have acceleration, but still the velocity will not increase continuously. Why? Because when collision will occur, everything will be reset. So even though the scooter has acceleration, if the scooter chalao for 1 hour, then will velocity become very high? No. Why? Because velocity increases and then something happens and then it starts from fresh again. Starts afresh, right? Same thing here. Collides, goes there, interacts, collides, interacts, like that. Okay, so that is how it will continue. So we cannot say that the acceleration is continuous and the velocity will keep on increasing. Or think of a bird as well. That also helps. Wind, say. So if you think that the wind is carrying the bird faster and faster, but what's a bird tree for business? Did you get that? What's a bird can business? Tree. So પછી બધું acceleration જતું રહ્યું, બધી velocity જતી રહે. Then once again when the bird will start, it will start again. Correct or not? Yes. Did you understand? So acceleration is not for infinite time. Acceleration is only for short time. પછી પૂરું થઈ જાય. પાછું short time પૂરું થઈ જાય. પાછું short time પૂરું થઈ જાય. So always the velocity will be like this. But this is for the ith electron. If we take the average, thus average of velocity for all the free electrons would be average of this. See, if you have addition like this, you want to take average. Then what do we get? Here you also will get average. Yes or no? Yes or no? And plus, here also you will get average. But here, you see, there is no need to take average. Why? Because everything is fixed. Charge of electron, electric field, mass of electron, and average relaxation time but already. Right? You know, another way to derive it would have been that we say that an electron will get acceleration for time અહીંયા પહેલા t લો પહેલેથી એવરેજ ન કરો તો પછી એવરેજ કરવી પડે અહીં સપોઝ t લો તો અહીંયા t આવશે but then that t will be different for all. Yes or no? Sure. Then you take average. So છેલ્લે તો આ જ આવશે. Make sense or not clear? Whether you already take an average and put it here or you take average later, ultimately at this stage you are always going to get minus E vector by me into tau. Here what we have used is, we know that on an average it's time tau. There is no doubt about it. In એટલું જ acceleration model, it's not like one electron is special and anything. There is variation, but overall the net effect is that the acceleration will be for a time tau. One time it may be more, one time it might be less. એવું બધું કરીને average કરો એટલે. So this is what we get. But what's this? Zero there? Kept zero there. Random. So because this is due to random mode, right? The first term here is due to random mode. સમજાણું કે નહીં? So basically, you know, the whole philosophy of this derivation is like this: that total velocity can be distributed into two parts. One due to random motion and one due to drift. समझ पड़ी? The total of random motion would be 0. So बाकी શું રહે? It would be due to drift, right? So here, let's write the second term. Now this is the average of velocity of free electrons in presence of what? In presence of electrons. In our definition, drift velocity is the average of velocity of free electrons in presence of an electric field in the conductor. In presence of electric field in the conductor. Okay. Therefore, Vd, it's a vector. Vd stands for what? Drift velocity. आज છે ને, आज average હતી ને. We found the average of the velocity of all the free electrons in the presence of electric field. Okay, Vd vector equal to minus E vector upon me into okay. બરાબર છે ને? આટલું નથી કે નોટ clear? આ formula યાદ રાખવાની. If you want to write it in magnitude form, then Vd equal to E into E upon me and then into tau. Okay. Can you identify the terms here? Vd for drift velocity. Vector no હોય તો drift speed here. E charge of electron. Capital E electric field. Tau time relaxation. Me mass of the electron. Clear? Okay. So that's the drift speed or drift velocity. Okay, our derivation પૂછે હો 2 marks આવે or 3, you know, very rare, but yes, you was it. Okay, any queries? અઘરું નથી એટલું. Steps તો બહુ ઓછા છે. Look at how many mathematical steps are there. You just have to write a few sentences. Average લેવાની એટલે 0 આવે એવું જ લખવાનું છે, બીજું શું લખવાનું? અને આમાં a into t એકદમ સિમ્પલ ચીટિંગ જેવું ડેરિવેશન એટલે તમે બોર્ડ એક્ઝામમાં નહીં કરતા હો. આ શેના માટે ખબર છે? જ્યારે એક્ઝામમાં ફોર્મ્યુલા ભૂલાઈ ગઈ તો હવે શું કરવું? તો કંઈ નહીં કરવાનું. Vt equal to simply acceleration into relaxation time. समझ पड़ी गई? acceleration શું થાય? force upon mass. તો force શું છે? E into E upon m. Is that okay? Okay or not okay? Clear? થઈ ગયું ને? કે ન થઈ ગયું? આવું નો બે સ્ટેપમાં પૂરું કરીને આવી ગયો આન્સર. મેં તો ડિરાઈવ કર્યું હતું. This is just an intuitive way to. Clear? પૂરું ને? આવડશે ને હવે આવું? Now, we will get an idea of how much is the drift velocity compared to the one due to random motion. Okay. So, પહેલા random motion માટે એક simple calculation કરું. Electrons are tiny particles, correct or not? So we can find their VRMS. Okay. યાદ છે? શું આવે? 3 kVt by small m. યાદ આવ્યું? Anti-theory of gases માં આવતું હતું ને? નહીં. There we used it for molecules going here and there. Here we are using it for electrons going here and there. Okay, so this is an estimate. So let's see, 3 into kb 1.38 into 10 raised to minus 23. Suppose at room temperature, so nearly 300 Kelvin, and mass of electron 9.1 10 raised to minus 31. Calculator, without calculator, whatever you like. Value 11.68. Square root કરવાનું બાકી ને? કરી નાખ્યું. Are you sure? Into શું? પાવર આવી કેટલા આવશે તમને? તો એનું સ્ક્વેર રૂટ નીકળવું છે તો કેટલું આવે? 10 raised to 4. 4 જ આવશે ને? બરાબર ને? સ્ક્વેર રૂટ કરવામાં ધ્યાન રાખજો. પાવર should be even તો જ થાય, નહીં તો થાય જ નહીં. Okay. So this is nearly 1.16 or 17 into 10 raised to 5 meter per second. Only speed electron amti am jai શકો inside the metal. Is that clear or not clear? But then why don't they go out? Because they hit or they interact with other ions. They will not allow it to go anywhere. Society માં રમવાનું, બહાર નહીં જવાનું. Okay. This is the speed due to random motion. Don't forget. This is the approximate speed due to random motion of the electron. But if you would consider the drift speed, okay, drift speeds typically are of this order. See the difference of power. This is 10 raised to minus 3 meter per second. And I will do 10 raised to 5. એટલે random motion તો એટલું બધું fast થતું હોય. It's definitely very important factor. Compared to that, the drift is negligible. But still, because there are so many electrons, બધા થોડું drift થાય તો એ current flow થશે. Did you understand? Okay, fine. Now, let's go over to the next topic. આ તો સમજાઈ ગયું ને drift speed. હવે બહુ important relation of current with drift speed or drift velocity. So suppose that there is a conductor, a uniform conductor with cross-sectional area A. So let there be a uniform conductor with cross-sectional area A. So surface area with cross-sectional area A and having number density of free electrons as n. Bracket में थोड़ा small n में explanation लगी तो small n means number density. Number density is what? Number for volume. Very easy. Number density means number of free electrons per unit volume. Meaning clear? Formula આવડશે ને ગમે ત્યાં જરૂર પડે number of free electrons per unit volume. N into E નથી હો, N of E છે. Be careful. Number of free electrons per unit. Okay. એને કહેવાય number density of free electrons. Now over here we are going to mark out a particular cross section M. Okay. And at some distance here there is a particular cross section here. Okay. Do you understand what I've marked here? Two cross sections, L and M. Suppose the distance between both of them is delta. You can also write dx. Okay, for smallest actually. Okay, you can write let there be two cross sections L and M at distance delta x from each other as shown. Okay. If free electron drift with velocity Vd or speed Vd, if free electrons drift with velocity Vd due to electric field E present in conductor. So if let free electron drift with velocity Vd due to presence of electric field in the conductor. Sentence को मोटर. When आगे बीजा sentence बोलो. Have you understood what we have written so far? We are saying that this cross-sectional area, how much is it? A. What is number density of free electrons? Small n. That is, in a unit volume, the number of free electrons will be small. The next thing is delta x. Delta x is the distance between two particular cross sections. They could be anywhere, right? Generally, we tend to take the distance small, but anything can go further. Okay, and suppose the electrons they are having what drift velocity? V. Now, for sake of simplicity, let's say electric field is this side. So drift कई बाजू था? If electric field is to the left side, then electrons will drift in which direction? Right side. Okay, there are a couple of ways to understand. One, you look at the drift velocity formula. Vector is minus E vector upon me into tau. Also indicate that if drift velocity is in if electric field is in one direction, then the drift velocity is in the opposite. Clear or not clear? Because of the minus. Electric field is this way, then it will apply force on electrons right side. So drift की बाजू तो आ जाए. Okay, understood? So you can say that all the electrons, or the free electrons, okay? All the free electrons between L and M will drift across M, will drift across M in a time which you can write as delta t or t del by delta t equal to delta x by vt. The time delta x by vt. What does this mean? See, although the electrons are moving randomly here and there very fast, but their random motion never contributes to any current. Clear or not? Yes, random motion the current no થાય. Current is only because of electric field. And what does electric field do that there is current? It gives drift. Electrons will drift because of electric field, and when electrons drift, current will flow. Everything clear about this? Now, so what I am saying is that if we are going to relate the current with drift velocity, then one thing is that current has absolutely no connection with random motion. Drift velocity nahi. Barabar nahi? The current has absolutely no relation with random motion. So when we are talking about motion of electrons right now, then we can ignore random motion because random motion will have no connection with current. So we are only considering drift. Now if we say that there are some electrons here, okay, all of them are going to be drifting in which direction? Right side. I didn't say moving. I said drifting. They might be moving here and there because random motion always continues. But we are not interested in random motion. We are only interested in drift. Because if by random motion, if one will go that way, then by random motion, one electron will also come from outside. Do you get that? So we are not worried about what's going on due to random motion. We are only worried about what's going on due to drift. Achha, so drift velocity can be Vd. Our distance delta x. Then do you realize that it takes time delta x by Vd for one electron to drift from here to here? How much distance does it have to drift? Delta x. So simple relation is बने कि नहीं? आगे समझेंगे. ये देखो. Delta x equal to Vd into delta t. ये लगाए क्या? ये नो लगाए. Delta x equal to Vd into delta t. So delta t is equal to delta x upon Vd. Clear or not? Sure. Now what this means is all the electrons that are within this section, all the free electrons, एक यहाँ से नहीं ये यहाँ पर नहीं by drifting. Clear or not? Clear or not? So then we can say that charge drifting across or charge flowing across, net charge flowing across M is Q equal to, if one electron goes, it will carry how much charge? E. If one electron goes, it will carry E charge. How many electrons are there in this portion and they are going to flow across M? Yes or no? So कितना flow થઈ જશે? જેટલા હોય એટલા બધા થઈ જશે ને? કેટલા છે? Capital M. Small m. Small m છે. તમે small m નો meaning શું છે? What is meaning of small m? Is small n number of electrons? It is number density of electrons. It's not number of electrons. समझ पड़ी कि नहीं? Small n is not number of electrons. So here it would be small n. Actually here capital N લખો, small n પછી આપણે introduce કરશું. Q is equal to Ne, where n is the number of free electrons between L and whatever were there in this portion, they all have drifted. कितना था? Capital N. That's what we are saying. Now we will not write answer in this form or relation in this form. We will put capital N's value. Therefore, Q is equal to small n into A into delta x into E. Did you understand? Get there. What is meaning of capital N? capital N will be equal to small n into volume. Yes or no? So how much is the volume of this portion? A into delta x. Everything clear? બરાબર ને કે કઈ ખબર જ નથી પડતી પ્રોપર્ટી ઓકે થાય સમજ પડી કે ન સમજ પડી yes small n into volume this is capital N and into E that gives you charge flow. Now why are we finding charge flow? Plan શું છે? Read the title. You get current. Have you already specified how much is the time in which this is going to happen? Time આવી ગયો charge flow થઈ ગયો તો current કે જાવ q by t. Understood the plan? So we are taking calculated steps only. To find current you need to get q, you need to get time interval. So પહેલા એવું વિચાર્યું કે if these are at some distance then in how much time all the charge will flow? That is delta x by v. And now we have also figured out that how much charge will flow. Okay, this much. Now we are going to divide so that we can find current. So this is the next. So we can write thus current in the conductor is I is equal to q by delta t. What's that equal to? N A delta x into E upon delta t. What is delta x upon delta t? VD. Yes or no? Sure. Yes. Absolutely. Yes. So thank you. Okay. મને એવું થોડુંક એવું લાગે છે કે આમાં મેં તમને વધારે પડતી ડિટેલ સમજાવ્યું વાર લાગી ને એમાં ખુશ થઈ ગયા બધા બરાબર ને જવા દીધો જ એમ ને તો હા હા આવડી ગયું કેવું લાગે સમટાઈમ્સ ઇટ્સ ઓલ અબાઉટ પરસેપ્શન ઘણી વાર એવું થાય કે તમને જેટલી ડિટેલ કહી ને એટલું તમને કંટાળો આવવા માંડે અરે આપણે બધું આવે છે આમાં કંઈ ખબર પડતી નથી બોલું એમ ને એમ સીધી લાઈન લખને કહે હા હા આવડી ગયું સર પછી જ ખબર પડી. Right? So I is equal to NE into VD into A. Next step. Current density. J is equal to what? I by A. I by A શું થશે? N into E into VD. Both are same formula. જે તમને યાદ છે રાખજો. Okay? બે એક જ છે ને? ખાલી એક વચ્ચે રિલેશન છે. J is equal to I by A. એટલું કરો તો આન્સર આવી જશે. ઓકે આની ટર્મ્સ બહુ જરૂરી છે યાદ રાખવી I for current small n for number density of free electrons E for charge of electron E for electron charge of electron VD for drift velocity of the electron A for sectional area. Okay barabar. Now we will end this particular topic by putting a very simple question in front of you. Answer તમારે જાતે વિચારવાનું. Suppose there is a pipe. Water જેવું વિચારો તો એ આન્સર સમજ પડે. Suppose there is a wire which is not uniform. અહીંયા એરિયા વધારે છે દેખાય છે અહીંયા એરિયા ઓછો છે. Is that okay? So if you connect it with a battery and current I will flow in and flow out. Obviously એવું થાય જેટલો in થાય એટલો જ out થાય. Is that okay? Then the question is, if you take a few points here, let's say A, B, and C, then you have to tell me which of these quantities are same and which are different. And if they are different at all points, then what is the order? Which is more and which is less? समझ पड़ गई ने? I, J, E. E for electric. VD for drift velocity. समझाओ? Turn it off. Okay.